Good morning, everyone. My name is Alan Holub, and what is on the agenda, actually today and tomorrow, because this is the first of a two-part class, is we're going to talk a little bit about Agile architecture. Just by way of introduction is that a lot of the work that I do nowadays centers around what I think of as Agile infusion work, which is to say coming into an organization and helping them move in the direction of using Agile processes. That, at least the way I do it, turns out to be a mixture of education and consulting and architecture and hands-on work. I started out doing it coming from the perspective of software architecture, just trying to help Agile communities be able to put together things in a way that worked. Is that one of the things that people don't understand about Agile is that architecture is a really significant component of getting Agile systems to function. Is that more often than not, when people think about Agile, one of the things that they think is that there isn't any architecture, that there isn't any design, and that everything is done in an ad hoc way at the last minute. And that's actually far from true. Is that the problem is not that there's no design. The problem is that the design has to be one that can accommodate the kinds of constant change that are implicit in an Agile process. And mostly what I'll be talking about then, today and tomorrow, is the sorts of things that one has to do in one's code in order to be able to accommodate that kind of process. So by way of introduction, before I even start into the slides themselves, let me spend just a moment to talk about what Agile is, just so that we can all be on the same page. When Agile is, get my thoughts in order here. Agile is really a completely different way of looking at software development than what most companies do. And I should say, by the way, that unfortunately, my guess is that even those of you that are in here who are working for companies that are claiming to do Agile are probably not doing Agile. Is that if you're doing any kind of estimation based on time, you are not doing Agile. If there are any deadlines based on time, if there are any benchmarks based on time, you are not doing Agile. Agile is fundamentally not a time-centered process. By the same token, Agile requires constant feedback and constant interaction with users, which means that an actual end user of your software must be in the room while you are developing. If you're not doing that, you're not doing Agile. So there's a lot of fake Agile in the world. Usually shops that are doing fake Agile are Scrum shops. And Agile is a complicated, interlocked set of processes, but more importantly, Agile is a culture. And unless the company has an Agile culture, it cannot really be Agile. It's just not going to work. So what happens in that culture is, as I said, very different than what happens in a normal culture, is that in an Agile shop, and I'll talk a little bit more about this tomorrow in the second part of this class, everything is based on what are called user stories, which are literally stories, small vignettes that describe the user in the process of doing something with the software that you're writing. And the story then is at the center of the whole process, in the sense that what you do as a developer is develop these small stories. It takes a couple weeks, usually, to put a story together, to put a story into practice, at which point you actually release it to your users. You'll get feedback from your users, ideally, immediately or close to it. And then you incorporate that feedback into the product immediately, which is to say the next release, 2 weeks later, is going to immediately incorporate user feedback. It's going to change the product. And the user is in charge here. It will literally change the product, which means that often when you're in the Agile world, you don't know what you're developing in advance. You think you know what you're developing, but until you get that user feedback, you don't know whether you're developing the right thing. Is that Eric Rice, who wrote a really interesting and I think valuable book called The Lean Startup, says it, I think, really well. He says, if you are developing the wrong product, the fact that you're doing it on time within budget is completely irrelevant. If you develop an on-time, in-budget product that nobody is ever going to use, you have accomplished nothing. Nonetheless, in most shops, the focus is all on that on-time, in-budget stuff. In Agile, we're not talking about that. We're talking about trying to develop a product that people actually want to use, something that's valuable to actual human beings, which is not something that's invented by a marketing department. It's not something invented by you, necessarily. Often the way that users use products is surprising. I was just talking to a friend at breakfast this morning, and we were talking about use cases surrounding the iPad. And I was up at Windsor a couple days ago, and I've passed at least half a dozen people that were taking photographs with their iPad. Now, who would ever have thought that? I wouldn't, right? That the camera would be an important part of a tablet, right? Because you don't think of a tablet's use cases as involving cameras. So the point is that unless you interact with the users, you're probably not going to be able to predict things like that. If the iPad, by some strange chance, turned into one of the major vehicles that people used for taking videos, that would completely change the way that the product would work. It would completely change the way that the software would work. And unless you get that user feedback, you don't know that. So everything in Agile then is based on getting feedback from the actual users of your product. Now, that impacts pretty much everything you do, because if you don't know what you're building until you start getting feedback, you can't be planning too much in advance. You can't have grand quarterly plans or yearly plans or something like that, because you're trying to build the product that people want, which of course is the way that you're really going to be successful, is by building the product that people want, not by building what you think they want. You can think of this as a marketing strategy, as Agile is a marketing-driven system in the sense that a sales-driven product is one that didn't exist before. You don't know whether there's a need or not, and it's your job as a salesman to create a need for this non-existing product. That's what selling is. It's creating a need when there was no need before. Agile is all about figuring out what the users really do want and really do need and build that. It involves research. So everything is done not by time, but by priorities. Is that if you do Agile planning, one of the things that you'll see is that they'll use something called a storyboard, which is a large tack board, typically, or a whiteboard with sticky notes on it, that list all of the stories. I mentioned stories a moment ago. And the stories are listed in priority order. So you can project time, because every story is going to take a couple weeks to implement. Once you get good at putting stories together, you'll be able to hit that target pretty well. And you can look at the board, and if everything is organized vertically by priority, and also horizontally by priority. So the highest priority thing to build is in the upper left corner or the upper right corner, depending on how you want to organize your board. But the point is that you're always working on the highest priority stuff first. But you look at the board and you see all of the sticky notes, and that tells you where you're going to be roughly 6 months from now. And then you look to one side of that 6-month benchmark, and that's all of the things that are going to be in the product in 6 months. As you're working, though, that board is changing. Its priorities change. Sticky notes disappear, new ones appear, people move priorities around. So management in an Agile process involves priority management, not time management. The assumption with time is that everybody's doing the best job they can. It's at the center of all Agile processes is the notion of trusting people to do their job. So everybody's trusted to be working at 100%. That's a given. So there's no point in ridiculous deadlines, because you work at the speed that you work at, is that you can't change that. What you can change is what you're working on. So that's the way Agile managers work, is they are juggling processes and they're juggling stories so that people are working on the most important things. The most important things will be done first. There aren't big releases because you're releasing every 2 weeks, so the product is developing incrementally. And in order to pull this off, the whole company has to be doing it. So the other side of Agile when it comes to Agile management is that you're developing software in a very different way, because that 2-week cycle has a lot of demands on it that a normal software development process cannot accommodate and a normal architecture cannot accommodate. Testing, for example. In an Agile world, testing happens simultaneously with product development. In many Agile processes, you develop the tests before you write the code. In all Agile processes, you are at least developing the tests as you're writing the code. If there are acceptance sorts of tests that just involve the user interface, those tests are being put together as the code is coming together. You're not planning months in advance, so you can't have a separate QA department because they would have nothing to work from. They don't have a grand plan that they can use to put together test suites so that 3 months from now, when the code is finished, they'll be able to run their test suite that they've been spending 3 months developing. That does not work. is what happens is that the QA is happening coterminously with the development of the software, which means that the QA people are integrated into the software development teams, which means that there is no QA department in an Agile organization, which is one of the reasons why so many organizations fail, because they're structured around things like QA departments now. And if you're going to move to Agile, the director of QA is not going to be very happy about the fact that the department is disappearing. So he's going to be working really hard to have it not happen. Politically, it's very difficult for an organization to move to Agile. The ones that are succeeding at that are the ones either who started out Agile or had somebody at the C level, the CEO hopefully, just determined to do it and won't put up with all of the political garbage that goes with preventing it from happening. And there are large companies that are doing that. Intuit comes to mind immediately. It's a pretty big company, and they are transitioning to Agile. They're about 4 years into that process. It's taking a while. But it's because the CEO is determined to have it happen. So I don't want to start off on a negative note by saying it's impossible to be Agile, because it's not. A large organization can transition. Intuit is a great example of that. But it's different. It's very, very different. So the subject of this talk, then, is how to write software in such a way that it can accommodate that kind of process. A process that is very rigorous, but it is built on principles that are not the sorts of principles that you're used to. You don't have long cycle times. You don't do a bunch of upfront requirements gathering in order to put together an architecture which you then implement, because you're doing the architecture and you're doing the implementing simultaneously. So if you're not doing upfront requirements gathering, what are you doing? Well, that gets us back to the customer in the room notion, is that normally what you would do is sit down with customers and you would spend weeks trying to figure out what they wanted and come up with some document that would describe that and then build a design from that document. Odds are that 80% of that document is garbage, as we all know if we've tried to do this. So the Agile philosophy is there's no point in gathering requirements which are unnecessary, which turn out to be not useful. Is what we'll do is instead of spending 6 months gathering all the requirements ahead of time, we'll take that 6 months and disperse it out through the entire development process. So instead of sitting down in a room with a user and doing nothing but saying, well, if we do this, should it work like that or should it work like that? You ask that question while you're writing the code. So you're still doing requirements gathering, but you're doing it at the same time as you're writing the code. So the code is changing constantly, and the code has to be structured in such a way that it can accommodate those changes. So there are two central principles that have to do with that. One of them is most of the discussion that we'll have in the next hour or so in terms of writing code in such a way that it's robust enough to be able to handle the kind of constant change that comes in an Agile world. And the other one is an architectural issue, which is not strictly speaking the subject of this talk, though I'm happy to discuss it with you offline. But the structure of the system has to directly reflect the user's image of how the system works. Now, computer systems are often not designed that way, because they're designed in some sort of crazy way that some engineer thinks is cool. And cool doesn't help here, is that if there is a disconnect between the user interface, which is the way the user's image of the system is, and the way the underlying system works, so there has to be some sort of elaborate translation between the UI and the underlying so-called business logic, then you're doing something fundamentally wrong, because as you make changes, it's going to be UI driven. The users are going to say, this isn't doing what I need, I have to do X. Well, that's the user's image of how the system works. And if the actual system doesn't match the user's image of how it works, then the changes are going to be very difficult to bring about. And one of the topics for tomorrow in the second half of this talk will be how to come up with systems that map into a user's image like that. Which is really part of a design process. But the system has to do that. So we end up with systems where engineers cannot do engineering stuff, which means that you guys have to stretch a little bit too, is that you can't be designing systems because of some theoretical technical advantage if that system doesn't match the user's requirements sufficiently that you can accommodate the constant change that the user is demanding. Is this making sense? I'm seeing a lot of concerned looks here. I never know how to interpret that. It can either be because I'm making no sense at all to anybody, or because it could be because everybody is completely in a disagreement with everything I'm saying, or it could be that I'm just not getting the ideas across, and I don't know that. If you have questions, you're welcome to blurt them out, is that I'm happy to be interrupted. But the point that I'm trying to make is that the code has to go together in a different way. It will look different. So for example, if you're working in an object-oriented system, and I imagine most of us are, the names of the classes, all, without exception, have to be names that the user would understand. If you look at the message flow between objects, when one object is passing a message to another, that flow has to make sense to your end users. They have to say, yeah, if these objects were people and they were doing this job, these are the sorts of things they'd be asking each other to do. And that's how you get that one-to-one connection, because the system is working the way the users are thinking. And since the users are driving this development process, that means that, again, if the thought changes, it's easy to change the system because there's a one-to-one correlation between the old thinking and the old system and the new thinking and the new system. So it's critical then to design around the user, very user-centric design. And people have been preaching this gospel in the object-oriented world for years. Most of the people that I consider competent believe this. Unfortunately, there are some large companies, particularly ones whose initials start with M, based in Redmond, Washington, who don't understand how object orientation works. Steve Sinofsky, I don't want to digress too much, but I've known Steve Sinofsky for years. Is that I started talking to Steve when he was working as a junior guy at Microsoft, what, 25 years ago probably. And Steve was in charge of the Windows 8 project, which we all know was just a ridiculous boondoggle. And Steve has subsequently left the company, not quite voluntarily, because of this. The attitude that went into Windows 8 has infused everything that Steve Sinofsky has touched, which started out with the Microsoft Foundation classes 20 years ago and has moved through every development system that Microsoft has given to us since then. And that attitude has been, oh, those users, they don't really know what they want. I'll give them this thing that I think is cool, and they'll like it after they use it. And the other attitude has been, and I find this particularly appalling, that users are basically stupid. By users, he means you guys, because he was in charge of the engineering side. And as an example, the Microsoft Foundation classes was very poorly designed from an object-oriented architecture point of view. It didn't follow very basic object-oriented precepts. Getters and setters, and I'll talk about this extensively in the next class, are evil. They are bad. You shouldn't use them. Last large system that I had that I worked on was about 200,000 lines of code. There were maybe half a dozen getters or setters in that entire system. And that's all there should have been. And I would argue that even those were probably not necessary, but I didn't have the time to get rid of them. So the point is that they've never been considered good. They weren't considered good 20 years ago. And I talked to Steve about this, and his attitude was, well, you know, the programmers who Microsoft are working for, they're old C guys. They don't know object-oriented. It's not our job to teach them what object orientation is. What our job is to get them productive. The best way to get them to productive is to give them a system that looks like what they're used to. They're used to getters and setters. They're used to working with structs, not objects. So we're not going to make everything private. My God, we're not going to do that, which is, again, another basic tenet of object orientation, that everything should be private. He's saying users aren't used to that. They're used to reaching into the objects and just changing stuff directly. So we'll set up our libraries so that they can do that. And I said, but that just violates every object-oriented principle on the planet. And he said, yeah, I know that, but I don't care. Is that the users are going to want stuff that they're familiar with. Now, the problem, of course, is that 2 or 3 years later, people started figuring out what object-oriented actually meant. And at that point, they'd be happy doing an object-oriented system. But Microsoft was stuck at that point in the older architectures because they had spent too much time and effort developing these older architectures. So you see that a lot. I don't want to harp on Microsoft because they're not the only ones, obviously, to suffer from these problems. The reason I am bringing it up, though, is that I know that many of us are Microsoft programmers, and much of the stuff that I'm about to talk about kind of flies in the face of conventions within Microsoft. So I'm going to warn you then in advance that Microsoft is not the world. And in fact, as far as living in the San Francisco Bay Area, in the Silicon Valley area, we tend to be out ahead of everybody else. Is that my experience traveling around doing talks and doing consulting work is that the US, for the most part, lags the Valley by about 2 years, maybe 3 years, and Europe tends to lag the US by about 2 to 3 years. You guys are about lagging by about 5 years. And which is not bad necessarily, because you can leverage all of the mistakes that we've made as you can do it right, which is a huge advantage, actually. But in the Bay Area, at least, Microsoft is dead. There are no new Microsoft projects of any significance happening anywhere in the Silicon Valley, none. And that's, I think, an important thing to observe. It's the only Microsoft stuff, the only things that are happening in C# are legacy projects for larger corporations. Now, that doesn't mean that the Microsoft will not continue to be significant, because, of course, there are legacy projects for large corporations, and those are going to go on forever. But I don't know any company that has fewer than 800 employees that's doing anything with Microsoft, any Microsoft technology. So we all have to start thinking out of that particular box, is that we all have to start learning about what object orientation and things like that mean from the perspective of everybody else on the planet. And we all have to stop thinking that the Microsoft architectures are the way to do things, because they're not. And most of what I'm going to be talking about are alternative ways to do things. So the basic issue then is this familiar versus correct problem. Is that it's easy to fall into the problem of thinking that just because I'm familiar with something, that's the correct way to do things. There's a lot of really interesting books that have come out recently that are worth reading. One of the most important ones is Daniel Kahneman is a Nobel-winning economist. Actually, he's not an economist. He won the Nobel Prize in economics, but he's actually a psychologist. And what he's interested in is, what does it mean to know something? People make decisions based on what they know. He's got a book that just came out recently called Slow and Fast Thinking. That's a really worthwhile read. I recommend it to just about everything. And it has to do with trying to understand why people know stuff and why they make decisions based on what they know and how what they know can be complete nonsense. And there's a lot of valuable information there, but one of the takeaways for this is that what you think of as correct tends to be the stuff that's familiar, and it also tends to be the stuff that your friends think as correct. So if you're in a small group and there's a kind of groupthink that goes on that's very real, where people don't even they can't even imagine thinking in a way that their friends are not thinking, as humans are basically social animals, and we develop opinions based on social networks, not on looking at facts. Interesting example that Kahneman has in one of his books. We've all seen the sort of brain teaser logic problem, right? Is that if it is true that some doctors are tall, and it's true that some doctors are men, is it true that some doctors are tall men, right? And people naturally go immediately, yeah, of course. And of course, if you know the logic, that's not possible, right? All the doctors might be short women, right? But the fact is that human beings don't work that way. We see a conclusion that we agree with, and then we don't bother to check the facts, because that's hard work. Actually, running through that logic is hard work. It makes your brain hurt. So you don't do it. If the conclusion looks good, you don't look at the things that led up to that conclusion. Well, that applies to software architecture in spades, is that we see in a conclusion that we like, and we don't look at the underlying issues. Model view controller is a classic example of that. We are presented with a conclusion, is that it's a good thing to separate the business logic from the UI logic. And most of us agree with that. So then people don't ask the next question. Does model view controller do that? And the answer is no, it doesn't. It doesn't provide any separation between the business logic and the UI logic. You change the underlying business logic, the UI is going to change. It always changes. You change the underlying business logic, things have to be displayed differently. Flow changes through the program, lots of stuff changes. So that means that every time you change the UI logic, if you're using model view controller, you are suddenly changing 45 controllers, 45 views, just because you made one change in the model. Well, that's not decoupling by any definition of the word. So model view controller does not do it. It doesn't decouple business logic from UI logic. But nobody ever asks that question, because they've heard the conclusion and they agree with the conclusion, so they assume that the logic that led up to the conclusion was correct. And in this case, it was not. So this familiar versus correct thing is very important, is that the correct has to be based on pragmatics. It has to be based on how things actually work. The other problem is something that's identified by what's called the Kruger-Dunning effect. As Kruger and Dunning did a couple of interesting studies quite a while ago now, probably it's about 10 years back, where they were trying to decide what people actually, whether people knew they were incompetent at something is the best way to express it. And he used grammar, English grammar, as a case in point. He said, he gave everybody a quiz asking them, how well do you know English grammar? And everybody put themselves in the 80th or 85th percentile, as high as the 90th percentile. Now, of course, you can't have a group in which 100% of the people are in the 90th percentile. It doesn't work that way, right? So he gave everybody a quiz and see how much grammar you actually know, and what you got was the usual bell curve that you expect. So the question is why? And the answer is that if you look at a grammatically incorrect paper and you don't know grammar, you don't know whether it's correct or not. You don't know the rules. So what do you do to tell whether it's correct? You look at the guy next to you. And if they think it's okay, well, then you think it's okay. And you're both wrong. And that's, again, a natural way in which people work, is that you tend to base your notions of correct on the opinions of the people that surround you, not on any kind of actual, pragmatic, real information. So we all need to read more, I think, is the answer to this problem, is that we need to understand more about the way the world works in general. But these two things, this familiarity correctness thing and this you don't know what you don't know thing, these are hard problems. And people get really upset about stuff, is that I've had to put up with death threats on occasion when I've talked about these sorts of topics. And it's just really, people get very upset about it. So, excuse me, let's talk about some of the basic principles that you have to put into your code in order to get you the flexibility that you need to survive in that agile world. OOP systems and procedural systems are very, very different animals. Object-oriented systems are clouds of peers talking to each other. In many object-oriented systems, the way that the OO system starts is main launches. It creates a bunch of objects, it connects them to each other, and then main terminates. So you have a cloud of peers talking to each other in order to accomplish something over some kind of event-driven network, usually. You compare that to a procedural system, and you have a centralized control, a spider at the middle of the web, main, pulling all the strands. Now, so functionally, it's very different in terms of the way that it's organized. More importantly, the data works in a very different way in an object-oriented system than it does in a procedural system. In particular, in a procedural system, largely the procedures, if you will, are filters on the data, is that you'll have a chunk of data that is passed from function to function to function, and each function does something with that data and then passes it on to the next function or modifies it or does something like that. Object-oriented systems are fundamentally different. An object-oriented system is all based around what's called messaging. And messaging is not just an inconvenient, weird word to mean a function call. Messaging really means that you have two objects that are defined not by how they do things, but by what they do. An object is not defined by what it contains, it's defined by what it does, what are called the object's responsibilities. So an object is defined by the set of public messages that it can receive. The way in which it handles those messages is completely irrelevant, or at least it should be completely irrelevant. Now, that lends us, it goes to a couple rules that I'll be discussing in a moment, but the basic issue then is that if the way in which the message is handled is not known to you, then all of the data that is required to handle the message should also not be known to you. It should be inside the object. It should stay put in there. So the data tends to not move. There's a rule there's a slide to this effect in a few minutes, but let me just break the suspense and give it to you now, is that in an object-oriented system, you don't ask for data. You don't say to some object, give me the data that I need to do some work. What you do is you find the object that has that data and you say, do this work for me. The concept is delegation, is what it's called, and this is what delegation really means. It means that what you distribute in an object-oriented system is work, not data. You don't move data around in order to work on it. That's a procedural mindset. What you do is find out who has the data and say, you do the work for me because you've got the data needed to do the work. So the data doesn't move. It stays put. It's all in one place. Very different organizational structure, which has some big advantages in the Agile world. Now, the next issue is that it has to do with flexibility. And again, in an Agile world, we really need that flexibility. So that notion that I don't know how an object works is something that gives me that flexibility because everything is abstract then. In other words, if you're programming everything in terms of interfaces and you don't know what the actual classes are, which you should be doing, that means that you have a lot of flexibility that you wouldn't otherwise have because your code will work on any class that implements the interface that you're programming to. So that gives you choices that you wouldn't otherwise have. And even something simple like data manipulation, right? If you're dealing with a collection or a dictionary or something that's very high up in the abstraction hierarchy of the collections, then it doesn't matter what variation of dictionary you're working on, whether it uses a hash table or whether it uses a tree or whether it uses something else under the covers, who cares? As long as it behaves the way I expect it to behave, I'm happy. And if the business requirement changes so that I need fast insertion instead of fast lookup, I can pull out the implementation of that interface, replace it with a different implementation, and my code doesn't care because it's programming to the interface. So that brings us back to this agility issue. Here we have a changing small business requirement, but a real requirement, and we can accommodate that easily in a way that is minimally invasive to our code because we've been programming to the interfaces. So abstraction is a good thing. Flexibility is a good thing. We want to be programming with the most abstract layers as possible. So we come back to the objects, right? An object is defined, again, by what it does, not by what it contains. This is a box. And I know that boxes contain things. The fact that this box contains an entire human being is not really relevant to me. I should say, this is a screenshot from a YouTube video. The video actually shows her getting into that box, which is really a remarkable thing to watch, is that you wouldn't think that human beings could bend like that, but she somehow manages to do it. But the issue here is that as far as the object-oriented system is concerned, it's not this kind of box. It's not a plexiglass box. You can't see what's in there. It should be a complete black box system. And what matters here is that the fact that there's a human being in there doesn't matter. What matters is that from the outside it's a box, and it has the characteristics of a box, and that's all that you know or you care about. So what you need to know then is, what does a box do? Well, the box has a lid that opens, the box has a lid that closes. You can put stuff in a box, you can pull stuff out of a box, that's all you need to know. The way in which the box works doesn't matter. And of course, we've all seen that with collection classes, for example, right? Is that you don't know how a collection class works by looking at its interface usually. You know you can put things in it, you know you can pull things out, but you don't know how it works. And that's correct. That's the way it should be. Okay? So then we have the delegation rule that I was talking about a moment ago. Is that the basic idea here then is that if you don't know how the object does its work, then you can't get information out of it because you don't know what information it has. More importantly, the information that it has can be changing radically as the system evolves. So if you are basing your code on knowing what's in an object, then you are limiting the ways in which the code can evolve. Because if you can't do anything unless you know what's in an object or what's in a class, then you can't change what's in the object or what's in the class, or you'll break too much stuff. The object really has to be opaque in order to be maintainable. And it really has to be opaque in order to be flexible, in order to be able to accommodate these changing requirements all the time. So you can't ever ask for information because you don't know what information to ask for. And if you did know what information to ask for, that would itself be a flaw, because it would mean that you can't change the object to contain different information. So you ask for help, you delegate. You say, do this for me. And you let the object do that however it does it. I don't know how it does it, but it's going to do it somehow. Everything involves the interface. I don't care about the fields. In fact, when you're doing Agile architecture, you don't really design fields as part of that process. I use UML occasionally, but when I use UML, I never put the attributes compartment. It's always empty. Because I don't care what the attributes are, the so-called attributes are. I don't care what fields it has. What I care about is what it can do. And the decision about what it contains, I'll leave that up to the implementer. That's fine. That's just part of implementation. So what we're striving here for is pure orthogonality. There's a hard word to say 10 times fast. Is that the notion of orthogonality is that when you change one thing, it shouldn't change something else. Two things that are orthogonal to each other have no connection. Right? Faith and science, as I put here. There's not much overlap. Right? There's some. We can have that discussion offline sometime. But the fact is that there is not much overlap. And somebody that's entirely on one axis doesn't understand much about what's going on the other axis, nor should they have to. Right? And that's the case with software systems also, is that the objects should be orthogonal relative to each other insofar as that's possible. Now, you can't have complete isolation, obviously, is that if you're sending a message to an object, you know something about that object. At minimum, you know that it can handle the message. But insofar as you can, you should have as much orthogonality as possible. Or to put it another way, you should be able to follow this rule, which I've named after myself because I couldn't think of anything else to do. Is that in order to have maintainability in this Agile world, you have to be able to completely restructure a class definition. Go in and rip out everything. Remove all of the fields. Remove everything except the function names, everything except the interface. And then rebuild it with a completely different implementation. And as long as the interface hasn't changed, nobody should notice. That's your goal. You want to limit the side effects of a change to 0. So that you can change as much as you want to inside that class definition without impacting everything. Now that gets us back to things like the getter and setter problem, which I'll talk about tomorrow. Right? If you're using getters and setters, you can't follow this rule because you can't change your fields, for example. So if you need to change the implementation so that none of the existing fields are needed anymore, where are you if there were getters and setters all over the place? Mm-hmm.
What about contract?
What about?
Contract between two classes.
Okay, so the question was what about the contract between classes? And it's the contract that I'm actually talking about here. In other words, the contract should be, I agree to do this stuff for you. That's what the contract is. The contract, people have perverted the notion of a contract over time to mean I guarantee that I have this information in me. And that was not the original, that wasn't Bertrand Meyer's original notion of the contract. He's the guy that came up with the notion of contract-based programming. The contract, from Meyer's point of view, was the interface. And in fact, the notion of an interface developed out of Bertrand Meyer's work on contract-based programming. Is the contract there was, I satisfy the contract defined by this interface. The interface is the contract. I guarantee to you that I implement these message handlers. And I guarantee to you that when you call this message handler and ask me to do something, that I'll do what you ask and return some kind of value maybe. Right? That's the class contract. What you contain doesn't matter. It shouldn't be part of the contract. And if you think about the metaphor, and the fact that contract is a metaphor, right, is that it stands for something that happens in the real world. There's not a contract on the planet for a programming project that tells you what the code must look like when the contract is over. Because that's why you wrote the contract, in order to develop that code. And the same applies to the contract for a piece of code within a class. The contract should not tell you what's inside the class. I don't care how the contract is satisfied. The contract is that I've agreed to do certain things, and that I'll do those. Mm-hmm.
How do you instantiate an object without specifying a lot of parameters?
Well, you might specify parameters, but I don't want to. The problem is we only have 90 minutes, and I don't want to digress too much. We have some slop here because we have a second part of this class, and I can move some of the stuff from this part over to the second part. But the short answer, and I'll deal with this a little bit more in the next class, so let me keep the answer short, is that if you are developing your code around user stories, and the code is reflecting the user's notion of the system, so the classes are the user's notion of what the classes should be, and the communication between classes are the user's notions of what the communication should look like. So that's what your public interface, your contracts look like. Then the sorts of things that you're imagining you can't live without, it turns out you can live without, because the notions of getting and setting things, the notions of providing elaborate details in order to create objects, that's just a habit that we have. That's not necessary. And it's certainly not something that appears to a user, as they don't know what's in the objects. They don't care. So if you design rigorously, and if you design with a lot of discipline in a certain way, that tends to change the structure of the system so the sorts of things that you're bringing up don't happen. And that's important, right? If you think about getters and setters as a case in point, the reason you think getters and setters are important is because you can't imagine how the class might be used. You're thinking of the class in complete isolation. You're saying, well, somebody might need this information, so I'll put a getter and setter around it. Well, I don't care about might. That's not a word that interests me. I'm interested in whether they do need it. And the only way to tell that is to write the program. So I never provide access to anything unless it comes out in the process of actually writing the program that I actually need the access. And even then, I'll say, I think I need access. Do I? Could I do the work in the object that has the information instead of getting the information out of it? And the answer to that question is usually yes. Take an object, your notion of, well, how do you construct an object unless there are lots and lots of parameters? It's your actual question. And the answer is, well, you could create an employee object with a constructor that had 40 parameters on it, or the employee object could go out to the database and initialize itself from the database. That's much better design. And then you don't have 40 parameters. You have one, an employee ID maybe.
How does that sit with single responsibility?
Let's table that for a moment. I'll talk about single responsibility in a second. Okay? So bad design, then, is something that comes up all the time in these contexts, right? So that's another important issue, is that there is such a thing as bad design. I've had people come up to me after I've done talks that are more focused on the design process itself, and they said, you know, in our last company, we followed the process that you're talking about to the T, and it was a disaster. Nothing worked. And my answer to that is this is not about process. Simply following a process is not going to give you good results. There is such a thing as a bad design, and there is such a thing as bad implementation. Following a process will give you a design, but it's not necessarily a good one. So we have to be able to recognize what good means. This is a picture of something that was designed badly. Is that somebody did all the requirements. Well, it's got to have a trigger, it's got to hold 6 bullets, it's got to have a certain amount of accuracy, it's got to have a handle that's got a grip on it that's not going to slip in our hands. They had all of the design stuff down flat. Somebody implemented the system based entirely on all of the upfront requirements that were gathered. It exactly satisfied those upfront requirements. It was done on time, in budget, and there it is. This is the problem with upfront design. So how do you recognize that a design is bad? There are a bunch of things that are hallmarks for bad design, and when I see this stuff popping up in my own work, this is a huge red flag. The one that always seems to grab me is the two that always seem to grab me is fragility and complexity. Right? I'm a programmer. I like complicated stuff. All of us like complicated stuff. We love it, in fact. And we never want it. If something is complicated, that's almost always bad. A good case in point, look at technologies which people do not use anymore. In the Java world, there's the enterprise Java Bean technology. 60% of the projects that were implemented under enterprise Java Beans never worked. Of the 40 that were left, 30% of those were so bad that they had to be discarded within 6 months. of deployment. This is a bad technology, which didn't stop the entire universe of Java programmers from jumping on that bandwagon for a few years. I was a CTO at a company where I was constantly arguing with people about EJB. They were saying, it's a web system, it's got to have enterprise Java means in it. And I'm saying, no, it doesn't. I won't touch that. It's too complicated. Anything that's that complicated is going to fail, right? Well, I tend to err in that direction, right? I go towards complexity. And that's bad, right? You don't want to be doing that. The notion of fragility, that's the other one that I personally break all the time. As I look at something and I go, well, if you change this over here, then you've got to change that over there too. And I'll put in a big comment that says, when you change this, be sure to go change that. And I catch myself after about 5 minutes and go, wait a minute, that's not right. That situation just shouldn't exist. So I need to restructure this code so I don't have this hard coupling relationship between two unrelated pieces of code, so that I can make the change in one place and it's done. So fragility is another, it's something that I recognize all the time in my own code, but it's because I'm looking out for it, is that the code is very fragile in the sense that if I change something in one place, it's going to break because other things depend on it. The opposite of that, rigidity, is just as hard. Right? Rigidity happens where everything is so connected in such a complicated way that you can't change anything. So there it's not that a little change, there's a difference between a little change is easy, but it breaks the code. And I can't even make this change. This is too hard. In order to make this change, 45 dependent things have to change, right? So getters and setters, again, I keep coming back to them because they provide great examples of bad design. That's a really good example of the sorts of things that make code rigid. Because I really want to change this field from a float to a double. But the ramifications of that are hideous. There's 1,000 getter calls. Every one of those getter calls are putting the result, the return value, into a float. So if I change it to a double, every one of those are going to break. Now, I could fix that with some kind of automated refactoring maybe, but every one of those values is then used in a subsequent arithmetic expression that might depend on a certain precision. So I can't just change the float to a double. I have to go look at all the equations and make sure they'll still work. This is a hard problem. This is so hard, in fact, that I'll just figure out some other thing to do. I won't make the change. So that's not going to work. Immobility has to do with the difficulty of reusing something. You're not using interfaces enough, is what that comes down to. Is you're programming for specific classes, or more to the point, you're taking a class that ought to be generically useful and making it so focused that it's not useful anymore. Now, there are a couple of other principles that we'll talk about in a minute there's some tension here between these rules and some of the other rules. With respect to immobility, the other flip side of that is that it's not really possible to design generic systems that are maintainable because they tend to be too complex. So there's some tension here. If you make something very generic, you're adding unnecessary complexity. So complexity, I think, stands alone in terms of what it says. Repetition is really bad, cutting and pasting. You never want duplication of your code. And you see a lot of that. I see a lot of this in Microsoft systems because there's so much boilerplate code that people tend to cut and paste a lot. And the problem with any cut and paste operation is that if there's a bug, even a small one, in the thing that you cut, the bug is now in the pasted place too. And you find the bug in one place, but the bug actually exists in two places. But if you've been cutting and pasting and then cutting and pasting and cutting and pasting, that bug has propagated out to many parts of the program, and it's going to be very hard to rectify the problem. So if there's any duplication of code, there's something wrong. There's nothing wrong with a method that's got 2 lines of code in it. That's fine. If I ever find even a 2-line repetition somewhere in my code, I will make a method or make a function that hides those 2 lines so I can eliminate the repetition. With the CLR and the JVM now, both of those systems are good enough at optimizing that these are not a problem. And then opacity, something that's hard to understand. That's really tied in. That's the second cousin of complexity. And again, if something's hard to understand, remember that the person who's maintaining your code is yourself. Right? Is that the code hits maintenance, as far as I'm concerned, 10 minutes after I write it. Because I know that 20 minutes after I write it, I won't have a clue how it works anymore. Maybe this is because I have children. But it's a problem, right? Is that you're writing for this mythical future version of yourself. So one of the solutions to these issues are the so-called solid principles. This closet is full of solid clothing. I really like this stuff. It's all carved out of wood. I've listed them here just so that you can know what solid stands by. I'm not going to expect you to memorize this slide because we're going to talk in depth about what all of these principles are in a moment. So let's talk about first one, the notion of single responsibility. A class should have a limited set of responsibilities, ideally just one. It should be responsible for handling one thing. It can delegate, but it still is ultimately responsible for providing the solution that it's supposed to be providing. So who it delegates to in order to solve the problem is not relevant. If the thing underneath doesn't work, that's not relevant. So, you know, a good example of that is the JDBC and ODBC libraries, both of them, are severely broken, right? Is that their goal is, and their responsibility, in fact, is to be able to get data out of the database and put data into the database. That's why those classes exist. However, they are very, very sensitive to the dialect of SQL that you're using to talk to the database, which is really a violation of single responsibility because it's saying, I'm responsible, but I can't do that thing because the database that I'm using doesn't do it. So does everyone see what I'm saying? If we're really following single responsibility, JDBC and ODBC should be saying, well, the database doesn't understand that dialect of SQL, so I'm going to have to change the SQL into something that the database does understand so that I can perform the operation that was requested of me. And it doesn't do it, so as far as I'm concerned, it's a failure. Now, the other issue has to do with the example that's here. And this also has to do with the notions of how to use derivation properly. Simply because you can say is a does not mean that you have a subclass-superclass relationship. English is very loose. Programming is very not loose. So you could argue that a manager is a kind of peon. Or I could say employee, I suppose, if I was being more corporate. But the fact is that the question as to whether a manager is a kind of peon or not depends on what managers and peons do. If it is the job, well, let's look at the other case first. Let's say managers and peons did exactly the same thing. Managers and employees did exactly the same thing. However, they were categorized differently. Over here, there's a pile of employees in a table called managers. And over there, there's a pile of employees and a table called peons. And over here, there's a pile of employees in a dictionary that is indexed by manager and it evaluates to a list of peons. But managers and peons do the same thing. They're just organized differently. There's no derivation relationship there at all. In fact, managers and peons are just the same class. They're all employees. They're just categorized differently. There's the real case of inheritance, the one that works, where a manager does everything an employee does, but it does a little bit more, and it might do a few things a little bit differently. That's a legitimate use of subclassing. But then there's the example that's up here, which is the timesheet system, which I actually wrote. This is a system I wrote for Schwab years ago. And the point is that the manager is responsible for authorizing timesheets. That's its job. That's its single responsibility. The peon is responsible for filling out timesheets, and that's all that it does. The fact that the same physical person sometimes logs onto the system in the role of manager and at other times logs into the system in the role of peon is utterly irrelevant. What I care about are the roles that they take on inside the system, not what their actual job description is. Is everyone seeing what I'm getting at here? So inside the system, these two things have a single responsibility. There's no overlap. There's no subclassing. There's no connection at all, really. They're completely distinct classes with their own responsibilities, and they do their one thing, and they do it well. So that's what single responsibility ultimately stands for. So how do you keep the responsibilities under control? I'm a big fan of CRC cards. CRC card is a very old design technique. 4x5 card. On the back of it, it has a list of on the front of it, it has the name of the class. That's the first C. It has the responsibilities of the class, a few sentences. And on the back of the card, it has the collaborators, which is to say the objects and classes that you can talk to, that you interact with. It's effectively a static model diagram, right? The stack of CRC cards in a UML static model diagram are just different representations of the same thing. And in fact, I don't use UML static model diagrams anymore. Because what I do is I take my CRC cards and I tack them up on a tack board, and then I connect pieces of string to the collaborators. That's basically a UML static model diagram. But it's much more flexible because it's all cards. I can pull them down, I can move them around, I can write new things on them. But if the responsibilities of a class won't fit on the front of the card, it's got too many responsibilities. That's a very practical way to approach design. If it doesn't fit, it's too big. Okay? The next one, the open-closed principle. This Dutch door is simultaneously opened and closed. So the basic idea of the open-closed principle is that it should be possible to change something without actually changing it. Which is an interesting concept. Those of you that sat in the design patterns class that I did yesterday will know that there are a couple of design patterns that are focused expressly on solving this particular problem. The idea is that insofar as you can pull it off, once a class is written, it should stay written. It's not a good idea to be going into a class and modifying it all the time so it does something new. Classic examples of that would be things like a class, if the class's data is not exposed, there are a couple of things that fall out of that concept. One of the things that falls out of the concept is that the class has to be responsible for generating its own representation. And by representation, I might mean a representation in a UI someplace, but I also might mean a representation in a database or an XML representation or a JSON representation, whatever you need. Right? Now, if a class is responsible for generating its own reputation, I was going to say its own representation, then you have some interesting design problems because let's say that when the program was first written, the only representation that you had to generate was a visual one for the user interface. And then a few months later, there's a requirement to distribute the user interface across the web, and now the class has to generate a JSON representation of itself. The temptation is to go into the class and modify it to generate a new representation. The problem is that never ends. Is that every month you go back into that class definition and you generate a new representation. And the problem with that is that every time you start generating new representations, new requirements emerge, you start have to jigger stuff around inside the class to get everything to work, which means that your tests may start failing and you don't really want them to start failing. You've got to start adding new tests to cover the things that weren't there before. And those tests are going to have to be run along with all of the other tests, which means the amount of time it takes to run all your unit tests has gotten longer. It's just a mess. So what you want is you want a way for a class to generate a new representation of itself without having to actually modify the class. I'll talk a little bit about this tomorrow in the session because we'll look at a solution to this specific problem tomorrow, which is the builder design pattern. Another aspect of that is the example that I've shown you here, where you have a frame object, a frame on a screen. And the question is, how do you handle layout? Well, you could use extension, or you could modify the class. In other words, you could have a frame that lays out its subframes left to right, and a frame that lays its components out right to left, and a frame that puts them on a grid, and a frame that centers them, and that sort of thing. But again, that never ends. You can't be going in and modifying the frame class every time you want to change the layout. So a design pattern solution to this problem is a design pattern called strategy. And the basic idea here is that you use something called a layout manager. In other words, this structure here doesn't work because there's too many changes that have to be made. If I keep adding things to that enum and modifying that switch, that's just untenable. So you don't want to do it, right? Is that there are better solutions. The best one is, again, this notion of the strategy pattern. So the basic idea here is that the frame uses a layout manager to lay out its widgets. It's a separate object. Now there's a tightish coupling in that the frame has to pass to the layout manager the set of widgets, so there's a slightly tighter coupling between a layout manager and a frame than we might like between two classes. But it's a controllable coupling. There's going to be a handful of these things. I know what they are. I know that if I change the frame in a really significant way that changes the widget system, for example, I may have to change the layout managers, but I also know that there's only 6 of them. All right, so the idea here then is that the frame's job, the frame's responsibility now, is to manage the set of of widgets, the sub things that it contains. That's its responsibility. And in terms of applying single responsibility to this, it's the responsibility of the layout manager to lay out widgets, not to contain them. So it doesn't care about removing them or adding them or anything like that. All that it cares about is laying them out. It's handed a list of widgets and it tells them how big they are and where they have to be. If I need to change a layout strategy, I write a new layout manager. Simple interface, it takes me 20 minutes. And I'm done. The frame can handle any layout manager that I give to it. Is everyone following what's happening here in terms of structure? So this is the open-close principle in action, is that the frame is closed with respect to modification. I can add new layouts without modifying the frame class at all. But the frame is open with respect to extension because I can add new layouts without any difficulty. So that seeming paradox is not actually a paradox at all, as you can have both. So insofar as possible, your classes should be organized that way, is that the extension of the class's capabilities should be done with a plugins kind of architecture if possible, not by actually going and modifying the class. So again, there are some caveats and some tension. I'll talk about them in a moment. Now the problem with open-closed, the big one, is that you can't predict the future. You can't really know in advance what's going to have to change. Could be that you thought that everything was going to be laid out left to right and you couldn't imagine a situation where it wouldn't be. So why should you go through all the trouble of that layout manager nonsense if there's only going to be one layout in the world? Or I can quote a former president of the United States who didn't actually know English. He never did get this right, is that he defaulted after a while to quoting The Who, which seems like a odd, to go from Abraham Lincoln to The Who is kind of an odd transition, but there we are. The point here, though, is that you don't want to, the fool me once, fool me twice thing. You want to apply that to software, right? So my take here is that the first time I'll do the implementation, I will do it in the simplest way possible. I will implement exactly what's needed for the current program, and by exactly, I mean exactly. I will not add anything unnecessary. Everything has got to be as simple as possible. I will never say, well, you know, if I added this extra argument, it sure would be a lot more flexible. Because that extra argument is a big deal. It might double the size of the method. It might triple the number of tests that you need. Every time you make a change, you've got to look at that code and make sure you haven't broken it. If nobody's ever using that argument, that's an awful lot of wasted effort. And if you do that on a third of the functions in your program, you've just added 6 months to your development time. You don't have time for that in the Agile world. You're on a 2-week cycle. You build exactly what you need, nothing else. However, if a month later a new user requirement came around and I now had to do both left and right to left layout, at that point I'd say, if I had to do it twice, I'm going to have to do it a third time. I will predict from experimentation here, from reality, right? I've had to make a change in exactly this part of the code, and I know that is a fact because I have to make it this week. I'm inferring then the odds of that change having to happen again are higher than I thought. So then I'll put the flexibility in. Then I'll add the design pattern. Then I'll add a little bit more complexity than was necessary for the simplest solution. But I don't do that until I discover that I actually need it. So design patterns and any kind of complex, generic solution to a problem, that's never my first place. That's never the first place I go. I always do it in the simplest possible way first. The other thing I'll say about this, not in the slides, but it's worth talking about, is that one of the principal practices in a full-blown Agile framework is the notion of constant refactoring. Is this idea that every time you look at a piece of code, you try and make it better. And there's a lot of things that fall out of this notion of constant refactoring. One of them is you better have unit tests in place. If you're going to be touching anything in order to make it better, you better make sure that you haven't broken something. So doing unit tests first is an essential part of the refactoring thing, two practices that interlock. All of the practices that comprise Agile frameworks interlock with each other. So you can't do refactoring unless you have the unit tests there. So things are changing all the time. Things are always getting better. So in the same way that the principles that I was just talking about might add a little bit of complexity, 6 months from now I might remove the complexity, and that's fine. Code is not valuable in the Agile world. If it doesn't do exactly what it needs to do, it's not valuable. You throw it out. But you can't do that unless your unit tests are in place, obviously. If you're transitioning to Agile with an existing system, your first task is to put in a vast number of unit tests, which I can guarantee do not exist. Next issue, the Liskov Substitution principle, an unfortunately complicated name. The basic idea here is that you have to be able to replace a subtype for a supertype, a subclass for a superclass, a derived class for a base class. The substitution always has to happen. So, or to put it another way, if I had a bunch of code written this way using stack, this is an example of a failure of Liskov, that I ought to be able to treat it as a list without any difficulty. Is everyone following me here? Now, lots of things can break Liskov. If you look at this example, this is a classic one, is that here I have a function f and it's being passed a list. And what I'm actually passing into it is a stack. Now, if you look at that implementation on the right, though, you'll notice that the stack pointer is down in the stack class where it probably belongs, right? The reference to the top of stack item. But unfortunately, you'll also notice that the clear method is in the base class, which means that I cannot actually treat a stack as a list because it's an error here to clear out all the elements without modifying the stack pointer. Is everyone following what I'm saying? Now, for that one, you could say, okay, I'll buy that one. I'll just override clear in the derived class, and that will solve the problem. And I have two things to say about that. It's that, first of all, that's work that should be unnecessary. And secondly, it doesn't solve all the problems. What about this guy? Add head. You never add something to the head of a stack. But add head has to be in the list. Putting an add head method in stack that threw an exception, that's an abomination. A method that doesn't do anything except complain that it's been called. You never want to take a compile time error and move it into runtime. That's a bad idea. Is everyone following what I'm saying here? So this is fundamentally incorrect, this structure. It violates Liskov substitution. I cannot treat a stack as a list and get away with it. So how would I solve the problem? Well, if a stack uses a list, I'm in much better shape. Is everyone following the UML here? I find that sometimes people can follow UML and sometimes they can't. I have a collection interface, which is implemented by both stack and list, so in a sense they can be used interchangeably. But that interface has nothing in it that isn't reasonably implementable by everything that implements the interface. You'll notice that there is no add head function in the interface because adding to the head of some collections is nonsensical. What does it mean to add to the head of a tree? You know, head based on which kind of traversal? I don't know. Right? So you wouldn't put that in the collection interface. It makes sense to put it in the list class. In fact, there might be a list interface that list implements as well as implementing collection that had add head in it, and that's fine. Sequential collection or something like that. Okay? By the same token, a stack is a collection. You can certainly add and remove things from a stack. This will turn into push and pop operations, but that's fine. You can clear a stack. Nothing wrong with that, provided that the stack pointer gets cleared. In other words, the stack can implement this interface just fine. But there's no danger anymore. So does everyone see what I'm saying? I've solved all of the previous problems by changing an inheritance relationship into a uses relationship. I've changed extends into delegation. So that's another really basic design principle that applies across all of our designs, is that we should minimize the use of inheritance, minimize the use of extends relationships, is that generally speaking, extends relationships are bad. I'll talk more about that when I talk about fragile base classes later. But generally speaking, we want to avoid them. And what we want to replace them with is some sort of containment relationship. It's always better to use an interface in a contained object than it is to use an extends relationship. And it's actually possible, always, to replace extension with a combination of an interface and a containment relationship. It's annoying sometimes because you've got to write a few extra lines of code, but it's always possible. I'll talk more about that later on. All right, is everyone following me here? The next one, the notion of interface segregation. You don't want clients to depend on methods they don't use. A classic example of a violation of this one was one that came up a couple minutes ago. The notion of you have to override clear in the stack class even if you don't want to, right? But a more important one is you have to override add head in the stack class to throw an exception. That's a strong violation of interface segregation, because there's no legitimate override. There is no legitimate version of add head in the stack. There's nothing that it could ever do. So that interface, the thing on the top, the thing that's requiring you to provide the add head method, is wrong. It's too big. So that's the general rule here, is we need to avoid fat interfaces. The fat is bad. This is actually, by the way, a real advertising campaign. They did this in the San Francisco area. It is obviously politically incorrect. It lasted for about 5 days. These billboards popped up. I managed to get a picture of one. They disappeared 5 days later, and that's the last that was ever seen of them. But I personally think it's a great ad campaign. Gives people real motivation to work out. But the issue here, though, is that fat interfaces that are big, that have lots and lots and lots and lots of methods in them, they're really bad. If you've ever implemented JDBC or ODBC, those are classic examples of that, is that the interfaces that comprise both of those libraries are huge. They've got 30, 40, 50 methods in them. And every implementation of ODBC has to implement those interfaces, and no implementation of JDBC implements every method of every interface. So both of those libraries say, if you don't implement this method, then throw a method not implemented exception or something like that, and that's just wacko. There's way too many methods in those interfaces. So that's interface segregation, is the interfaces should be tightly focused. And really this is just a variation of single responsibility, is that it's really saying that the interfaces themselves should be focused on one responsibility. And if a class implements too many interfaces, that is itself a red flag, because that is itself saying, well, if an interface represents a responsibility, and you're implementing 15 interfaces, that means the class has 15 responsibilities, and that's over the top. There's something wrong there. You won't see that if the interfaces are too fat, because everything will appear simple. There's only one interface I'm implementing. What's the problem? So by working with interface segregation and single responsibility together, by combining those two concepts, we'll end up with code that's much more maintainable. We will be able to see problems in the source code because the definition for the class extends out to 8 lines, right? And we can fix them because the problem is so obvious we can't ignore it. So there are a bunch of bad smells here. The notion of extends that has generic capabilities associated with it, right? That you're extending stuff and everything is too complicated, too generic. There's a bunch of stuff that you don't need in the base class, in other words. You find empty implementations of interface methods, right? Things along those lines. Changing an interface method affecting classes that don't use that method. That's a really classic one. In other words, I've changed the interface, I've added an argument to some method, and I have to change 35 classes as a result, and I find that 25 of those classes could have cared less. They never used the argument, or maybe even didn't override the method. Right, those are all classic examples. So how are we going to fix some of this? Here's a classic example of inheritance used incorrectly, but demonstrates the problem. I have a typical event model. I have a timer. I have a listener. The listener gets notified when the timer expires. I have a lock. We could treat the lock either in the sense of a multi-threaded kind of lock, or we could treat the lock in the sense of there's a lock on a door that has to open. Just think of it as a lock. And the point is that I need a timed lock, too. I need a lock that expires when the timer expires. Now, the clue that something's wrong here is that all locks don't need to be timed locks. But in order to get a timed lock to exist, if I'm just using an inheritance system, I have to have that situation. So is everyone following what I'm getting at here? So the solution looks a little bit more complicated, but is actually a little bit simpler. And there's an even simpler version of this we'll look at in a second. But the idea here, though, is that here I have the timer and the listener as I did before, but by using an adapter object, I can have a lock class that's just a lock, then I can extend it to have a timed lock, and now the timed lock uses the adapter. Right, now let me simplify just to make it really obvious what's going on. Right, I've eliminated the adapter, and I still have the same advantage, though. So see what I'm getting at. So we come back to this repeating, recurring pattern that by replacing inheritance with some kind of containment relationship, we end up in a better space. So everyone following what I'm getting at? Dependency inversion is an interesting one. I went down and actually saw this sculpture. It's pretty cool. It's a real tank. It's not a cardboard replica of a tank. It's a real tank. This is the world's noisiest sculpture. And it's certainly inverted. This will stop after a moment or we'll hypnotize us. We'll all be staring here looking at her running for the rest of the talk. The basic idea of dependency inversion is that sometimes dependencies go in the wrong direction. Well, I'll wave my hands around in the air and try and describe a couple of situations. But actually, before I wave my hands, let's look at a high-level situation that demonstrates the problem. Here's a typical three-layer application. Now, the issue is, which way do the dependency relations work in the sense of if I change something, what's impacted by that change? And when dependency relationships are done incorrectly, we can end up with dependency relationships that go in the wrong direction. And I definitely think that if I change the way that the underlying system works, I should not have to change my business logic in order to accommodate that. Again, that because of the agility problems, right, is that the business logic is going to be changing a lot. So certainly I don't want stuff going in the other direction either. But I don't want minor refactors at my database layer to force me to go in and change business logic. So the dependencies are going in the wrong direction because the business logic here is using an interface that's defined at the mechanism layer. Is everyone understanding the difficulty? Now, how can we fix that? If I move the interface up to the policy layer, and notice that what the interface is doing is changed completely, right? In the little picture, what is now the little picture, the interface was the database connection. Is everyone following me here? Now the interface is the customer. So what I'm doing is I'm requiring my mechanism layer to essentially wrap the database by implementing policy layer interfaces in a way that makes sense to the database. Is that the job of the mechanism now is to hide what the database even exists. This is, of course, something that we see all the time. This is just an entity layer. This is the way that the Microsoft Entity Framework works. This is the way that Hibernate works. This is the way that JDO works in Java. Is that we're saying instead of talking directly to a database in my policy layer, what I'm going to do is be able to import and export business-level objects, employees, and I will let the persistence system take care of the problems of talking to the database for me. But by moving the interface, by saying customer is an interface that has to be implemented by the persistence layer, I have isolated myself from all database level changes to the program. I can swap out one database, replace it with a completely different database, and my core business logic doesn't even notice that that's happened. So from a maintainability point of view and from a flexibility point of view, I'm in a much better position. Is everyone following what I'm saying here? So the idea then is that the dependencies have reversed. This is why this is called dependency inversion. Instead of the policy layer being dependent on a database system, we now have a situation where a persistence layer is dependent to some extent on the business logic because it has to implement the business interfaces. But mostly that's going to be automated. And even if it wasn't, the persistence layer is really just providing a bridge, to use another design pattern term. This is the bridge pattern we're looking at, in between the database layer and the business logic layer, and that's fine. Is everyone seeing how this is working? So that's on the big scale. Let's look at it on a smaller scale. Imagine a world in which we did not have an event model, right? In other words, if a button press turned on a lamp and we didn't have an event model, we'd have to do it like this. And this makes the dependency inversion, or at least the need for dependency inversion, painfully obvious. We really do not want our button class to be dependent on the lamp class. A button is a completely generic thing. We want to use buttons all over the place. We don't want them tied into specific classes in the system, because that would be crazy. We'd have to, the button would be huge because it would have dependencies to everything that the button had to notify. So we can introduce an interface in order to do a dependency inversion. Right? So the basic idea, the Hollywood principle, right? Don't call us, we'll call you. Is that the idea here is that the lamp now notifies a generic button listener, which notifies the button. But notice that the dependency relationship has reversed. It used to be that the button was dependent on the lamp, and now the lamp is dependent on the button, and that's a much better position to be in. So by introducing interfaces at the correct level, we can invert the dependency. Right? So that's another question, though, in terms of design that you need to be asking yourself all the time, is that what's going to change? You don't know exactly what the changes are going to be. There's no way to predict that. But it's easy to imagine what is going to change of all the possibilities. Some things, the odds are going to be lower than other things. You'll always get this guess wrong, but it's usually a pretty informed guess. You'll be right 80% of the time. So you think about that in advance, and you try and set up things so the dependency relationships go in the direction that makes sense in terms of the likelihood of a change. You want to be able to change the thing that's going to change most often without impacting anything else. So nothing should be dependent on the thing that you expect to change. The direction of that arrow is important, and you need to be thinking about the direction in which that arrow moves. Okay? Question. So again, I suppose there's nothing particularly agile about any of this stuff. This is all just good design. But in the agile world, it's essential that you do these things. Because if you don't, you can't be agile enough. You're on a 2-week cycle. You don't have the leisure to do things wrong. You can't be sloppy. You've got to be thinking about this stuff all the time, or the code just won't work. So the notions of agility then impact everything, all the way down to small decisions that you make when you put the code together. So having a checklist of these solid principles, for example, when you put a piece of code together is important. So go through it and see if it's going to stand up to these kinds of tests, because you need that kind of rigor in the code in order for it to be able to stand up to the constant changes, to the constant new requirements. All right, questions?
Actually, I have 2 questions.
Mm-hmm.
Maybe it's one answer. But
Okay.
the one is, like you said, it's nothing about Agile. And architecture to be agile architecture?
Well, what makes it, so the question,
The second question, how architecture is applied on agile cycles?
there are two questions, right? One is, I haven't mentioned the word agile, so what makes this particularly agile? Then the other question is, how is architecture applied from an agile perspective? The second one, there actually are slightly different questions, and I'll talk more about the second one tomorrow. The first question though, there's nothing that's particularly agile here, but everything is agile here. What I mean by that is that every one of these principles will make any code better, whether it's agile or not. However, if you are programming in an agile world, you do not have the option of not doing this. Is that if you are sloppy about any of these things, I can guarantee you that you're going to slip your 2-week cycle. I can guarantee you that the code will degrade to the point where you will have to throw it out within 6 months if you're not doing this kind of stuff. It will get too complicated too fast. So the real issue with agility in respect to this particular discussion of very low-level architectural issues is that we've all known that we should be doing this, but none of us have been doing it, probably. Has anybody here been doing every one of these things in all of their code? Anybody? Has anybody been doing any of these things in any of their code? I see a smattering of hands, about 2/3 of you, and that's good. But all of you should be doing all of them. Right? And the issue is that as you move into an agile world, you have to write the code in such a way that it can handle that stress. Code in an agile shop is under an enormous amount of stress. And you don't see that in a long-term development project where the code is in development for 8 months before you do any releases. Because there's always a week or two to fix things. There's always time to fix stuff. In the agile world, there is never time to fix stuff. It has to work perfectly out of the box. And you have to be able to change it quickly and have it continue to work without wasting a lot of time getting it to work again because the change that you just made broke it. And it's this stuff that makes that possible.
Actually, not agile architecture extends architecture, but opposite.
Yeah, you know, it's not, right, exactly. It's not that agile architecture is an extension of normal architecture. It's really the inverse of that, right? So you could argue that agile architecture is just good architecture. We should have been doing it all along, but we aren't. So let's think about what we're doing, right? It brings me back to my original notions of Daniel Kahneman and all that stuff of we think as being correct the things that the people around us think of as being correct. A lot of this stuff is not important to a lot of programmers. If you're in a shop where people don't even know about it, or if they don't think that some of these principles are important or stuff, odds are that you're not actually doing this because nobody thinks it's important. And it is important. It's the point that I'm trying to make. It is important. And you can't take the old ways of thinking and move that into a new process and be successful. I saw a hand over here.
You talked about getting the customer in the room. Say you have 50,000 users of your product.
Well, you're not getting all 50,000 of them in the room.
How do you mitigate the risk that the one that you do have in there is an idiot?
Is an idiot.
Yeah.
The problem of the customer as an idiot. The customer is not controlling the world. You do not build the thing that the customer tells you that he wants, because the customer often doesn't know what he wants. What you do is you have, ideally, a customer who has proven by experience to be a good customer, the guy that asks you the right questions, the guy that's asking for things that other people have been asking for. That's the guy you want in the room. And you verify, though, that what you're doing is correct by constantly releasing to a larger body of customers. You're making a release every 2 weeks. Now, you might not be releasing to everybody, right? There's a lot of companies that are large, that are doing Agile, do a staged release kind of thing, where every 2 weeks you're releasing to 200 customers, 200 new ones. And then if the feedback came from that and it was okay, then you'll do a larger release to 2,000. And if that's okay, then you'll go out to the whole customer base. Right? So there's often these kind of phased releases that happen in the Agile world. But the point is that you don't necessarily trust the customer who's in the room. You want to make sure that the customer's direction was correct by actually releasing to a larger user community and seeing what the response is. And the response should ideally be something that's measurable. Something on the order of people are using this more. Or people who used to spend more time in this part of the program than we wanted to are now spending less part of the time in this program, right? In other words, if you were doing a tax program, the fact that people could get their taxes done faster, that's a good metric. You don't want them to be spending more time in there, right? So it's not just the customer in the room, it's also the larger body of customers that you're releasing to, who are then validating that the guy in the room is giving you good advice. And if he's not, then pick a different customer.
But how is that validation done? You're going to have people that go out and actually get information from those customers.
You might have to have people go out and get those information, but often you have a lot of information at hand without having, it's there for the taking, you're just not taking it. You'll see this more with web-based applications, admittedly, than you will with a client server or just a pure client application. But with a web-based application, you have vast amounts of information about how the customers are using your application. You can track every click. You can track every mouse movement if you want to. I'm not recommending that you do that, but you can. Right? You can do A/B testing in the web world. You can release version A to 50% of your customers and version B to the other 50% of your customers, and then you can compare the results and see which one works better. Real A/B testing, right? I've said A/B testing has its own issues. I've worked for many companies that have done A/B testing incorrectly, where they tried to build that into the source code and stuff. And there are a bunch of good A/B testing frameworks, and you should just use one. But the point is that in the web world, and that's the direction everybody's moving. Another piece of completely unsolicited advice that's reflecting the general thinking around Silicon Valley right now is that if you're building a client-side application, you are doing something fundamentally incorrect. You should just stop instantly. Go do something else. Raise beans or something. Is that all applications will be cloud-based very shortly. And I don't know of any non-cloud-based applications that are being developed right now. So if everything is cloud-based, well, then you've got a lot of feedback there. And there are other feedback metrics, though. How many people are buying the product? What are the reviews like? That sort of thing. But you can also go out and do traditional, focus groups and user groups and sit down and watch people interact with it and that kind of stuff. We all have a huge source of feedback that we tend to not leverage, which is our customer service division. Is that you get an enormous amount of information about the quality of the product from customer service. When 10% of your customers are having a hard time using some feature of the system, that's a valuable, incredibly valuable piece of information, which most companies throw away. Right? The customer service department knows that 20% of the calls that are going to come in deal with this issue, so they've worked out a workaround, which they've distributed to all of their guys, and they've got these little crib sheets, right? When this problem comes in, read this workaround to people, and nobody ever tells the engineers what the workaround is, or that the problem even exists. So that's not good, right? So the customer in the room is a big customer. And there is a physical customer in the room, there has to be, but you're always validating the information that you're getting against the larger world. Right, the opposite of that, while we're on the topic, I'm digressing a little bit, but I think we have time. Yeah. The opposite of that, while we're on the topic, is that the customer is not driving the process. The customer is providing you with the answers to questions that come up as you develop. Right? And the only time that a company has a customer driving the process is a time when the customer is really a super customer. Apple is a classic example of that. Steve Jobs was the world's best customer. He could understand cool better than anybody else on the planet. So he said, you're going to build what I tell you to build. He was a customer who was controlling things with a sledgehammer. And he got away with that because he was Steve Jobs. This is not a model that can move to any other company. I know all these people that read these manage as if you were Steve Jobs things, and that's crazy. Steve was the worst manager on the planet. I knew Steve Jobs. He smelled bad. He dressed badly. He was mean to people. He screamed at people. He would stomp around and have tantrums. You don't want somebody like that in your company. And the reason he could get away with it is because he was such a good customer. He could figure out what customers wanted before the customers knew what they wanted. And that was a skill that is a 1 in a 10 million skill. There aren't many people who can do that. So managing like Steve Jobs would be insanity if you were not also Steve Jobs the Coolmeister, Steve Jobs the super customer. Okay? All right, so let's go back to our actual agenda here. Talk about extends relationship. This guy on the bottom is being extended. As you can see, he's not enjoying the process. There are, of course, many kinds of inheritance in the world. Interface inheritance and implementation inheritance are the important one. Everything I'm going to talk about right now is the extends relationship in the sense of being implementation inheritance. The only reason I bring this up is some of us are going to be working at languages that don't distinguish well between implementation and extends, between implements and extends, is that Java does it pretty well, C# does it less well, C++ doesn't do it at all. So the notion of interfaces is very important, right? This idea of a class that has nothing in it but a description of things that you must implement, which is really just a coding way of doing a class contract, as I mentioned earlier. That's good. Implementing many interfaces is good. There's nothing wrong with that. Extending, in the sense of deriving a subclass and overriding methods, is bad. It's unavoidable sometimes, but it's never good. So let's look at why. First of all, you lose flexibility if you're not using interfaces, right? Again, this is sort of basic OO design stuff, so I'm sure that most of us know it, as we can go through it quickly. The idea that if you're programming here in terms of collections rather than linked lists, you're in a much better position. So for example, the linked list requires us to have linked lists. If we want to change the linked list into some other kind of list, we can't do it. So if we use the collection instead, we can pass any linked list in at all. Now, everybody, I'm assuming, knows that. What you often don't think about is that there are other alternatives. So for example, here, I've replaced the notion of the interface with a completely different interface, iterator. Right? So G2 used to be passed a collection, which meant that it could operate on any collection. By passing it an iterator, it can now operate on anything that we can get an iterator across, and that's a much larger set of things than just collections. I can get an iterator across a database results set. I can get an iterator across an input stream coming in across the network. I can get an iterator across strings. I can get an iterator across lots of stuff that aren't collections. So by thinking in terms of even more abstraction, outside of the class hierarchy per se, you can end up with even more flexibility than you would end up with than if you were staying inside the class hierarchy. Abstraction is good. So if all that you are doing with the collection inside your method is pulling an iterator out of it and then iterating across the collection, you're better off passing the iterator in if it's flexibility that you want. Now notice this is a decision that is neither helping or hurting our complexity metric. It's not making the code more complicated or less complicated. It's just making the code different. So here we have a situation then where we can put flexibility into the system without any of the negative sorts of repercussions that we were talking about earlier. Is that we get good solid flexibility, but we can do that now instead of having to do it later because there's no negatives. There's the notion of the ISA test, which I talked about a bit earlier. This notion that you can't use ISA to determine whether a subject, or not a subject, to determine whether derivation is really appropriate, whether you should be using a superclass-subclass relationship. Is that ISA makes sense in English. It certainly makes sense when you're reading, right? When you say a linked list is a list, right? That's useful. That's valuable. But ISA gets you into those situations that we were looking at earlier where we were incorrectly saying a stack is a list, which is not true. You're telling me to stop? Is it that late? Oh, I'm over. Okay, so let me, as I said, we can slide this over into part 2, so we'll do that. This is all stuff, the next few slides are things that we talked about anyway. So why don't we stop now? Let's make this our break. What we'll do in part 2 is I'm going to do 2 things. I'm going to talk more about fragile base classes, which is what I just started on. I will talk a little bit more about the getter-setter problem that we were talking about earlier, and then I'm going to talk about the process of developing a design that will fit into an Agile system, and then how that process can be leveraged in order to come up with a particular architecture. So those are the three things that we'll be doing tomorrow in the second part. So I will see at least some of you tomorrow, I hope.